What makes DevOps rollbacks so difficult for failed deployments? Imagine trying to undo a complex change in a busy factory. It sounds simple, but in reality, it can be a huge challenge. That's what happens in software when a deployment fails and teams try to roll back. It's not just flipping a switch. Several factors make this process tricky and sometimes even risky. First, think about the system state at the moment of failure. When you deploy new code, it often changes the application, the database, and the infrastructure. If the deployment fails, the system might be in a mixed state. For example, the code might be updated, but the database schema might not be. This mismatch can cause errors if you try to revert just the code. Restoring to a previous version without fixing the database can lead to data corruption or missing information. This is especially true for systems that store data and relying on specific configurations. Next, consider how many parts are involved. Modern software often runs on multiple services or microservices. When you update one part, others might also change or depend on it. If you only roll back one service, the rest might still be running the new version. This partial rollback can cause unpredictable behavior, data inconsistencies, or even system crashes. Coordinating the rollback across all these components takes careful planning and precise execution. Automation helps in DevOps, but it's not always enough. Some rollback steps requiring manual work, especially when dealing with infrastructure changes or database migrations. Manual steps introduce human error, which can slow down recovery or make it less reliable. If a team forgets to revert a configuration or misses a step, the system might stay in a broken state longer. Monitoring and detection are also key. If problems aren't caught quickly, the window for a clean rollback closes. Without real-time alerts or automated health checks, issues can go unnoticed for hours or days. When that happens, the system might have accumulated more changes, making it harder to revert everything properly. Deployment strategies like blue-green, canary, or rolling updates can reduce the impact of failed deployments. These methods create separate environments or gradually shift traffic, making it easier to switch back if needed. But they requiring extra setup, resources, and planning. For example, blue-green deployments need duplicate environments, which can be costly. Canary releases need traffic routing capabilities. Not all organizations have the tools or skills to implement these techniques smoothly. Finally, keeping a clear history of all changes is essential. Version control systems and artifact repositories help teams track what was deployed and when. Without this, identifying the last good state becomes difficult. Regularly testing rollback procedures is also important. If teams don't practice these steps, they might find out too late that their plan doesn't work as expected. So, the difficulty in rolling back failed deployments comes down to the complexity of modern systems, the need for coordinated changes, the limits of automation, the importance of quick detection, and the necessity of good change management. Overcoming these challenges requires careful planning, the right tools, and regular testing to keep systems resilient and recovery smooth.